Hello, everyone. Dr. Vaughn. I'm going to record a couple videos for you tonight. We're going to look at 9.3 and look at first the hypothesis test for the mean when the standard deviation is known. This is called a z-test. It's not common, actually, because the standard deviation is not usually known. If we knew that much about the population, we probably don't need to run a hypothesis test on it, because to know the standard deviation, you had to know the mean. And you don't need to run a sample to, but it could be known. It does happen. It's based on empirical data, perhaps, and you want to see if changes have occurred over time. So anyway, first we're going to formulate the null and alternative hypotheses. This we don't need the spreadsheet for. It's going to come right from the statement of the problem. So let's read it carefully. So the charges to a client on the assumption that telephone surveys can be completed in 15 minutes or less. And if it's longer, a premium rate is charged. So then we're going to have a sample size of 35, and we're going to use a known sigma of 3.3. So our alternative hypothesis, we want to know, whether this can be completed in 15 minutes or less. And so this is going to be less than 15. The equals always goes on the null. And since this is a one-sided, less 15 minutes or less, the alternative is going to be greater than or equal to 15. I hope I got this right. I'm a little addled right now. All right, so for the rest of this, the test statistic, the p-value, and then the conclusion, we are going to use the spreadsheet. So first, we're going to enter the sample size. Now, you can do a formula for the sample size, even though they kind of told you what it was over here, 35. But you can use a formula for it by just doing a count equals count of the number of data entries that you have. And then close parentheses. And you can see there are 35 of them. Now, the mean, just like we did last week, we're going to do equals average. That's the sample mean. And close parentheses. All right, here's the hypothesized mean value, the population standard deviation, which was given to us in the problem. It's already been entered for you, the level of significance, and the standard error. So the standard error is equals the standard deviation, which is right here, the population standard deviation, divided by the square root, and in Excel that's SQRT, of the sample size. So the standard deviation divided by square root of this, I'm sorry, I think we want to do, yeah, just what, that's right, divided by square root of this sample size, close parentheses, and that's our standard error. The critical value, we're going to get a little bit later. And so let's just kind of calculate the test statistic. All right, so the test statistic, I'm going to do this one first, so we'll go back and get the critical value. The test statistic is going to be the z-value of your sample mean using the standard error. So I'm going to do equals the test statistic, the observed sample mean, I'm going to put in parentheses, minus the hypothesized mean, and divide by the standard error. All right, so that's the x bar minus mu h, the hypothesized mean, divided by the standard error. Now, for the critical value, this takes a little bit of thought, but on a z-curve, it's a normal distribution curve. And on this case, we have a one-tail version of the test because it was less than and not greater than. So we're going to put the entire alpha value, and the alpha value here was 0.01. So we're going to put that entire alpha value up into one tail. So what I'm going to do here, there might be an easier way of doing this, but what I'm going to do here is equals, I want to get 1 minus because I want the above norm.dist where I put in the observed test statistic with the mean and the standard deviation. So I need to put in cell D15 here. I'm just going to type it. And then the mean and the standard deviation. I'm sorry, I think I want to use the, hold on, I'm going to pause for just a minute. Okay, I'm back, I'm sorry. So you're going to use norm.in for the inverse normal distribution. We're going to put in 0.99 because, I'm sorry, we want 0.99 below this value, which is the critical value, and 1% above. So that's 1 minus alpha in this case. And then we'll do the mean of the distribution and the standard deviation, which is known here, and close parentheses. But actually, I'm going to actually put in 0, 1 because we want this on the standardized normal distribution table, which is a mean of 0 and a standard deviation of 1. So our critical value is 2.326. So this is our test statistic, our critical value. You can see that the test statistic is above the critical value, so we would actually be rejecting the null hypothesis in this case. Now let's hop over into MindTap for a minute. Let's see if I'm actually doing this right. I think that we want to switch this to being greater than, and then this is going to be less than or equal to 15. I'm going to put in my test statistic here of 2.504, and they want 2 decimal places, so that's going to be 2.50. And then they do want the p-value. So let me show you how to do the p-value. It's for an upper tail. So the p-value, what I want to know is the probability of getting a result more extreme than the one that I observed. I'm going to do equals norm.dist, the normal distribution, because we're running the z-test, with this value with a mean of 15 and a standard deviation of 3.3. I'm going to say cumulative true. And this will give me the area below, but I want the area above because it's an upper tail. I'm going to do 1 minus. And I have something that's not quite right. Oh, I know. Right here, I want to put in again 0 and 1. Because we're on the standardized normal distribution curve. And go back and put the equal sign in. And get a p-value of 0.006. And that's 4 decimals. They want, that's 3 decimals, 0.0061. And then is the premium rate, the p-value is low. The p-value is less than alpha. And so we can kind of reject the null hypothesis, and the premium rate is actually justified because it is different enough to be marked as being significant. So let's see how I did. And okay, I struggled a little bit. I'll chalk it up to being in the hospital, but I think I eventually got this one complete. Thanks. And in the next video, let's look at the sigma not known.